This GNAV question concerns the difference between a track error angle and the drift affecting an aircraft on a particular leg. The question reads as follows. A pilot is flying on a track of 270 degrees true towards the Zulu Victor Romeo VOR. At 10:20 UTC, they plot the position and determine that the aircraft is on course. At 10:32 UTC, after having travelled for 60 nautical miles, the pilot plots the position and it's 10 nautical miles off track towards the south. Given the following information, calculate the average drift from 10:20 to 10:32 UTC. The TAS is 280 knots and the forecast wind vector is 150 degrees at 30 knots. And the optional answers are 5 right, 10 left, 5 left, 10 right. But note that what we're doing here is asking for the drift, not the track error angle. To look at it in diagrammatical form, the green line is the track we wish to fly, 270 degrees true. And what we see here is that between 10:20 and 10:32, we have diverged to the left or to the south, and we are now 10 nautical miles south of the track, which means that the track we've made good is actually 260 degrees true, not 270. Now, the 1 in 60 rule says that if you are 1 nautical mile off track after 60 nautical miles, then the track error angle is 1 degree. So in this case, we are 10 nautical miles off track after 60 nautical miles, and therefore the track error angle is 10 degrees to the left. So that is the track error angle. However, that is not the drift. And the reason for that is that the drift is simply the difference between your heading and the track made good. And obviously, in our pre-planning, we have decided to use the TAS of 280 and the forecast wind to work out what heading to fly to, we hope, fly 270 degrees true. And to find out what that heading is to fly, we would have to use the CRP5. So we need to use it and plot in it the TAS and forecast wind vector and then the track to work out what heading we should be flying. So if we look at our CRP5 here, you'll see that here the wind direction 150 is underneath the true heading index at the top. You will also see that the central dot is on our TAS of 280, and we have counted 30 knots down from that central dot and put a mark for the wind vector. What we're going to do now is put the desired track underneath that heading index, and that would obviously be 270. When we do that, the wind mark we've made will move, and in this case, it'll move to be overhead the 5 right drift ray. So when we do move that track up at the top there, the wind mark will be over the ray here. We now match the track 270 at the top of the CRP5 with 5 degrees right. As you can see just here on the right-hand side. And you'll notice then that the wind mark has not moved off the 5 degrees right drift ray. So we can now read the heading we would need to fly to maintain flight level, to maintain a track of 270 under the true heading index. And that would be 265 degrees true. Now we can go back to our diagram. We've already seen that our track made good was 260, and we know that the drift is the difference between our heading and the track made good. So if we pop our heading of 265 degrees true onto our diagram, we will see that the angle between that heading and the track made good is the drift we have experienced between 10:20 and 10:32. So the drift is 5 degrees left. So remember that the drift is the difference between your heading and the track made good, 5 degrees left in this case.